Welcome to Bugcrowd University. Today we're going to be talking about broken access control testing, missing function level access control, IDOR, and more topics. My name is Jason Haddix, and I'm the VP of Trust and Security here at Bugcrowd. I'm a father, hacker, blogger, and gamer, and today I'll be presenting this module for you. Today's module outline is going to have us review the module reading, review the classes of access control bugs, which includes IDOR, MFLAC, and a couple others, review some tooling, and review some resources and reference and tips and tricks. For today's module on access controls, there are two guides that you should be reading along with. One is the Web Application Hackers Handbook 2, and the other is the OWASP Testing Guide version 4. Chapter 8 in the Web Application Hackers Handbook on attacking access controls, and 4.6.2, 4.6.3, and 4.6.4 of the OWASP Testing Guide on bypassing authorization, privilege escalation, and insecure direct object references. So we're going to discuss just a little introduction as to what an access control bug is. Access control bugs currently sit in the top 10 of the OWASP top 10 at number 5 currently for the 2017 version. Before, access control bugs actually occupied two different spots if you had them split out into different variants: insecure direct object references and missing function level access controls. Access control bugs in general have a lot of names associated to them. You'll hear insecure direct object reference or IDOR. You'll hear missing function level access control, MFLAC. You'll hear access control bugs presented as privilege escalation and authorization bypass, or business logic flaws, or forceful browsing, or parameter manipulation, and even path traversal and local file include could be considered access control bugs. So this is the most obvious incarnation of this bug, simple numeric IDOR. A function usually called with a parameter is passed a numeric value somewhere. Because this function lacks basic access controls, you can change this numeric value to something else and retrieve data that doesn't belong to you. You can see acme.com on the right has an ID parameter, and that value of the ID parameter you might have seen in your traffic logs in Burp is 43976. Now, if you iterate that down one to 43975, you might be able to access someone else's data. For this variant of the bug, it all depends on what the impact has for the specific function. Priority and payouts are largely based on what kind of damage can be done by iterating to another person's account information. Hopefully your IDOR that you are finding has some real impact on the application and the program owner, and it will be rated as such, usually in the P1 or P2 range if you find something of that nature. We just looked at a simple IDOR, a numeric-based IDOR. Now we're going to delve into other classes of broken access control. The first area we're going to look at is indeed insecure direct object reference, but we're going to go over some case studies in different IDORs that you can see in the wild. So we previously saw a function that would allow us to view someone else's data in an IDOR with a GET request. This is the same thing, but in a POST request and executing a different function. Here you can see our URL says /account/delete account, and in our POST body we have account ID and action, or ACID and action. Here we have a ACID of 4321 and an action of delete. Most likely you would iterate here on the 4321 number, trying to delete someone else's account. Here we have an example of a GUID-based IDOR. This incarnation of the bug can also fall under missing function level access control. Let's say that you're browsing with your account and somewhere inside of your request traffic, you see this numerical identifier called ID. Now, right off the bat, fiddling with this doesn't change anything in your account, doesn't let you access anybody else's data, and it's pretty long to be able to be brute forced. So we can then, as a user, create a second account and do the same workflow in that account. And now we get assigned a different GUID. Now, if we completely log out of the account and then log back into it under account 1, we can issue requests with the GUID from account 2 and all those same functions. You may be able to change that account's password or do anything else on the site. Now, having to find another user's GUID, because they're long in this case, lowers the priority a bit. But usually in applications like this, there's other endpoints that might leak GUIDs of other users. When you're working with a GUID-based IDOR or missing function level access control bug, It's important to try to see if you can get a UUID for another user without having to create an account yourself. To try to enumerate GUIDs or non-enumerable account IDs, look for other endpoints or web services that might return this data. To do a quick search in your proxy history will help you find your ID, and those functions should be looked at first to see if you can tamper with them to get somebody else's ID. And sometimes that can be a vulnerability by itself. Many times there are endpoints that will translate other information into a UUID, like an email address. These functions can sometimes be used to get targets, GUIDs, and emails are much more enumerable than a random string. You can also use search engine scraping to try to view results of functions that maybe got cached on search engines and see if you can steal UUIDs that way. You can look through the functions of any associated web or mobile application. These often return a lot of data and sometimes can leak UUIDs or random IDs. It's also pertinent to really verify that the UUID or the ID is random. Sometimes IDs that seem overly complex only have portions of them which are actually changing, and the rest are actually static, making them actually easier to iterate upon. Here you can see we have a request on the right-hand side of a GET request to /API/data/email address. And this is meant to simulate a mobile API that maybe has a function that allows you to get user data if you know ID. Now, this function to any developer actually doesn't seem like anything bad because it's only returning maybe a role name and an account ID and the UUID. But this is actually the information that the attacker was using for in conjunction with something like a GUID-based IDOR or GUID-based missing function level access control check. So you could easily enumerate users on that platform because email is much easier to enumerate, and then you will get back their UUID and maybe some other information about their account. So what we're looking at here is a request to an account/update passwords endpoint. And this is a hash-based IDOR. Now, the user ID parameter in this request is a MD5 hash, but IDOR function values can take many forms, including a generic numeric string, an alphanumeric string, a hash, something that's encoded, an email address. You can really use a lot of things, and so it's important to look at the parameter values for anything that represents your account or your ID inside of the application to see if you can fiddle with it. One thing to look at when you're trying to exercise these type of attacks is paying close attention to the request method that's used. A lot of time REST APIs or other applications use put or patch to update data for these types of attacks. You also notice that the target here is changing an email. We have a put request to account update email resource, and inside that is some JSON data that has the account name and the old email and then the new email. Now, if we are going to try to IDOR this function, we would want to fiddle with the new email address so that we could try to change it to badguy@badguy.com. Now, if this was the only IDOR inside of the application, once we've changed the email address, we'd have to figure out how to get into the account from there because all we've done is update the email address. But luckily, a lot of sites use technology to do a password reset. And if we've already changed the new email to badguy@badguy.com, instituting a password request would have the new email sent to us, and we could go ahead and take over the account that way. This is a variant of an access control bug called local file inclusion or path traversal. These variants usually use a function to render or include some type of page. If we can supply an arbitrary path, we can sometimes get content back from the server. Path traversal and LFI will be covered in Bugcrowd University in their own modules. Here you can see a request to a view resource with a PG equals terms and services. Most likely that's meant to bring us back to a terms and services page. Now, if we change that PG equals to ///////Etsy password, we might be able to ask the server to retrieve a local resource that's not the terms and services page, but is instead a copy of the Etsy password file on the server. We could also change that to any other file path. If we knew a name of a file on the server, we could probably return the source code for that page. Now we're going to talk about missing function level access controls and some variants of this bug. So one variant of missing function level access, or MFLAC, is static pages and what people call forceful browsing. Many times, applications have administrative backends or views that are only meant to be viewed internally. Sometimes they're behind logins, but sometimes you can directly access the page with sensitive data on it by just forcefully browsing to it if you know the path. In some cases, these pages might be protected with things like htaccess files or access rule sets, but they can be subject to misconfiguration and bypass. In the example on the right, you can see a GET request to /admin/view transactions gives us an access denied. But if we do another request with get/admin in uppercase and view transactions, we might get the access that we need. Another variant of missing function level access can actually exist just on static files. Sometimes static files are also subject to access control failures. Images and documents are key to secure when they deal with really private data. Here you can see in the right-hand side that patient images might have a predictable username for images that are associated to patient images. And if you can enumerate this and go to a different image that's not yours, that's obviously a breach of confidentiality and trust. There's also the idea of patient documents here, where PDFs might be being stored somewhere, maybe not even the main site, maybe this is on a different site or some kind of storage server, but being able to easily enumerate these without any access controls and get other people's documents is also very bad. Even if pages themselves are access controlled, many times their functions, if called directly, will not be. It's important to separate the page that renders the output and the actual post and GET requests that return data from it when thinking about access controls. Here, in the previous example, we saw the /admin/view transactions page, if we were to browse to that endpoint, might be protected. But if we directly reference the data we want, like /admin/view transactions, and then we provide any parameters that we might have gained that we know that this function takes, like admin equals true, and a from date and a to date, we might be able to pull back data because the access controls are not scoped all the way down to the function level. Now we're going to talk about parameter manipulation and logic flaws, which can be related to or verbatim access control bugs. So parameter manipulation is somewhat related to access control bugs. Here we can tamper with the price value. If we can edit the price value and try to set it to something negative, we might be able to get the application to give credit back to us somehow. The post request here is to a store by endpoint for some type of item, and we're adding this to our account with an action of add, but setting a -15 value for the post request price parameter. Parameter manipulation is a workflow that you're going to be using a lot during application hacking, most often in Burp Repeater. And so some of these will akin to logic flaws, or people will call them parameter manipulation. Sometimes they're actually just access control bugs. The logic flaws are a variant of missing function level access control, usually involving a multi-step workflow where an attacker can skip steps of that workflow to his or her advantage. On the right-hand side here, you see a 6-step type of workflow to purchase an item. The first step is you add an item to your cart, and then you check out, then you enter your shipping information, then you go to payments paid, enter your credit card information, then you get a purchase confirmation, and then you receive your item. Now, in this workflow, we can do the first 3, add an item to a cart, check out, and enter our info, and then we can try to bypass the payment method and go directly to the purchase confirmation method, and then maybe we will receive our item. Logic flaws, and this one in specific, this is a quintessential example of what people do when they talk about logic flaws, but it's not always a payment purchasing workflow. Sometimes it's an editing document workflow. Sometimes there's just multi-step problems with these type of things. Now, what happens a lot of times is actually this presents itself in two-factor authentication. Many people who try to roll their own two-factor authentication will develop this in a way where they have one stage where you enter your username and password, and that is one function, and then a second function to ask you to enter in some type of third-party nonce or token or something. And then what happens is that you can completely bypass that page and go directly to the inside of the application because a cookie has already been set and you didn't actually need to verify the third-party token or whatever it does for your second factor authentication. Now that is an authorization bug, but it is also somewhat of a logic flaw as well. Now we're going to talk about some tooling and tips for doing IDORs and missing functional level access control attacks, and just anything else that we can help a bug hunter with knowledge around these vulnerabilities. One thing to just get in your head when you're looking for these types of bugs is that many times the most critical IDORs or missing function level access control bugs are only uncovered in the deepest parts of the application and functions that are highly embedded inside of these apps. To find this type of vulnerability, you really need to make yourself a power user of the application and what it does. That means if the application has multiple user roles, signing up for everything with 2 accounts, and really understanding all of the things each of those accounts can do. The more used your application is, or the more you use your application and the more familiar you are with it, the more of these types of bugs you can find, and usually the more money you can make by finding these types of bugs. So there are some likely parameters or keywords to check for when you're looking at IDOR. Statistically speaking, these are pretty common parameters: REST path names, keywords, and functions associated with IDOR, missing function level access control. These were gathered through a statistical analysis that Bugcrowd did of the type of bugs that come into the Bugcrowd platform. And most often when we saw things like IDOR, we saw these parameter names on the left-hand side of this table, things like ID, account, order, doc, email, profile, user, number, no, key, group, and edit as the most common culprits for IDOR. And then any numeric values that were in parameters that were under 10 digits, or that were under 10 digits in REST numeric paths. In functions, most often missing function level access control presented itself in change emails, change passwords, upgrade or downgrade user roles, creating, removing, updating, deleting specific application level data, and in shipping, invoicing, and document viewing, most likely. So this tip has to do about applications that are maybe purchased or open source software or paywalled in some way. Now, if you find one of these applications and you're up against it when you're doing application testing, often you might identify this by maybe the name of the application embedded in the source code or something like that. And if it's something that's purchased, like a COTS piece of software, common off the shelf, or an open source project or a licensed piece of software, a small investment into installing the application yourself so that you can map out roles and functions that you don't have access to on the client's hosted version of that application can really yield tremendous results. If the application is COTS or paywalled, you might have to pay a small amount to get access to that. But if you can look at the help docs, a lot of times you can view pathing and roles and all that information inside of the help docs, which are usually freely available. You can also request a demo from the software creator licensor or the SaaS platform that is putting up the paywall, and maybe you can garner the requests and the research you need to find access control bugs in that software from those methods as well. So another tip here is to create a function matrix for your missing function level access control bugs that you're looking for. Now, when testing for MFLAC, it can be useful to create a matrix of all of the application functions and who should have the ability to exercise them. Here on the left-hand side, you have your user roles, which is admin, user, and unauthenticated. And then you have, along the top row, you have update password, update email, change account data, upgrade account to admin, and view logs. And these are all the functions that you identified that might be sensitive. And now the admin should have access to everything here, and indeed, yes, they do, and they should. That's indicated by text, and green means yes, they could do it. Now here, a user should have access to update their password, update their email address, and those are working as expected. Green is good. And they should not have the ability to change the whole accounts data or upgrade any accounts to admin. Since those are filled in, I have marked that those are green, and that's good as well. But the access level for a user to view logs should be no, when in fact that user could actually view the logs by directly referencing them. And so you can see that box is filled in with red. So the text indicates should they be able to do it, and the color indicates if they could do it. So unauthenticated also has the same bug, should not be able to do anything in the application, but yes, indeed, they can view the log page by a missing function level access control bug or a direct browsing bug. So if you're to this point already in the training, you've probably gone over the introduction to Burp Suite. But for most IDORs, what you're going to be using to iterate or exploit them is Burp Suite's Intruder tool. And usually that happens by heading to Intruder, sending your request to Intruder, and then you have your positions tab, and usually you'll iterate on like maybe the last part of the ID that you want to iterate up and down. And so after you do this, you'll go to your payloads tab and choose number as your payload tab, and institute, maybe 3 digits here that you go over all the combinations for. And you'll run attacks on this, and then you'll sort things by their content length or their response code most often. Or maybe you'll use the grep function to pull out text from the response to see if responses were different somehow in a place that you expected them to be. Burp Intruder really is used to exploit most IDORs in the industry today. So with that idea of the missing function level access control table that we just looked at, the function table, there's also some things that do that type of stuff inside of Burp, but not verbatim inside of Burp. There are extensions that can be downloaded from the B App Store for access control testing. Now, there's a few of them. There's auth matrix, there's auth-z, there's authorize, and now there's a new one, auto repeater. What you're viewing here is a screenshot of auto repeater. They all have different advantages and interfaces. I suggest that if you get really serious about looking at these things and you feel like one of these can give you an advantage, you definitely check it out. A lot of times these bugs can be basically exploited manually with repeater and intruder, but if you want to do a full matrix style type thing inside of Burp, you could probably use one of these plugins. A lot of people are actually using auto repeater now. It's created by NCC Group, and it's one of the newer ones that people seem to be liking for this type of testing. Here's a list of references for some of the extensions that we've talked about. I've also included some links here to their blog posts or videos on YouTube, how they presented these tools at conferences. So feel free to go check those out as well. Normally we would include with one of these vulnerability classes, maybe people who are really up to date in this type of vulnerability. There's not that many people really who have made a name out of discovering IDOR bugs. Everybody kind of discovers once in a while, and they can be complex, and there's definitely lots of write-ups out there, but there's no one person who is really considered like the uber master at it. So there's no Twitter list to monitor for advents and this type of thing. You just have to continually learn, continually discover themselves, and maybe play a few CTS and find some in the wild. Lastly, I just wanted to thank you guys for tuning into this module on broken access controls, and we will see you in the next module.